Welcome back, students. Prushti sir now. We're discussing today the Wheatstone bridge application. All of you must be aware of Wheatstone bridge. Yes, sir. No? All of you must be aware of Wheatstone bridge. What is that? It's a combination of registers in this manner, as you can see. This is the EMF source, and this is R1, some register, R2, R3, R4, R5. This is a Wheatstone bridge, and in general, current flows in all the 5 resistor branches. Okay. So there is also something called balanced Wheatstone bridge. What is balanced Wheatstone bridge? If R1 by R2 is R3 by R4, no current flows through R5, that bridge resistance R5. We call this balanced Wheatstone bridge. This is known as balanced Wheatstone bridge. If we ask you to calculate the equivalent resistance for this is the total current in the circuit, which branches into I1, I2, then I3, I4, I5, like this. So R equivalent will be the EMF source divided by total current, will be the equivalent resistance of this combination. Yes or no? So I have to calculate the I1, I2, then I have to calculate I as I1 plus I2. By how to calculate, going through the loops. What you have already done, you must have done all that. So this is I1 minus I5. So you must be knowing all this, and then you will be getting you just applying the Kirchhoff's law. You must be in a position to calculate the R equivalent. But if the no balance, if this is unbalanced bridge, then we have to solve for the different loops and find the I1, I2 and get the E by capital I. Is it okay? But suppose it's a balanced Wheatstone bridge, since no current will be flowing through the R5, then I can remove this even if it is joined, but no current is flowing. So this is as good as removed. There is no potential difference across this, and this is because I5 is 0, then I1 will be flowing through this, I2 will be flowing through this. That means R1, R2 will be series, R2, R4 will be series, and both these upper and lower branches will be in parallel very easily. Or you can say, since there is no potential difference across this, R1, R2 in parallel, R3, R4 in parallel, and both these parallel branches effectively will be in series with each other. Yes or no? either you will get the correct answer. But it's simple. I'm not going to discuss on that. Now my question is, if it is not balanced, but symmetry is there. Let us see what I mean by this. Now see this diagram. This is R1, R2, R3, R4, you call this R1, R2, this is R2, R1, okay, and there is a EMF source with a switch. This is the EMF E. There is a switch here. This call is R0, and this. Are you observing that whether it is tell me whether it is okay. Is it balanced? R1 by R2 is not equal to R2 by R1 in general. Yes or no? So this is unbalanced. R1 by R2 is not equal to R2 by R1, so unbalanced. Wheatstone bridge. That means current flows through the R0, the bridge distance, call it I1, I2, let's say this current is capital I. So from symmetry, you can see if I1 flows through R1 and I2 flows through R2. If I reverse the cell, then same I1 will flow like this, and I2 will flow like this. If I reverse this polarity cell of this, reverse the polarity of this cell, then current which is flowing to R1 here, R2 here, looking from this and this, we can see A, B, looking from A and looking from B, this identical arrangement of the resistors. So if I reverse the all cells, in this case only one cell is there, then the current in existing cells will be reversed, means I1 will flow like this, I2 will flow like this. After getting reversed, so before getting reversed or in this situation, I1 must be flowing here, so that if I reverse the cell, it will be reversed like this in this direction, and I2 must be flowing like this, so that if I reverse the cell, I2 will flow like this, I1 flow like this, as expected from this diagram. So I use the symmetric condition. This is my loop 1, loop 2, and this is loop 3. 3 independent loops, and this current will be this I1, this is I2, then this current must be I1 minus I2. You may say, why not this direction? It can be. These are arbitrary values. It can be either this way or this way or that way. Okay. So this is the situation. If I ask you what is the equivalent resistance here, how will you do this? Okay. Let me solve this in a very typical manner by solving. This is by going through the loop here. I write the Kirchhoff's law by going this loop. Let's say I go in the clockwise manner in this loop. This loop and this loop will be similar same equation, because they are, I have used the symmetry for both these loops, same currents and same resistors. So I go in this loop. So if I go from A, call it as C, call it as D, A, C, D, A loop, the triangular loop, then I'll go through this R1, then R0, then R2. So like this, then what should be my equation? Here I am going in the direction of the current arrow mark. So I see a drop of potential. Here also a drop of potential. I am traveling in the direction of current arrow mark. But here I am going opposite to the current arrow mark. So I see the rise of potential. So as you know, with the basics of this. So I will write now. So minus I1 R1. I show every step of here to you. This is minus I1 R1. Then again minus I1 minus I2 R2. Again minus I1 minus I2 R0. But here I see a rise of potential plus I2 into R2, and the whole closed loop overall is 0. Okay. Then I rewrite it in a convenient manner. So see. Okay. So now we are in a good situation. Let us write I1 R1 dash is equal to I2 R2 dash. भाई R1 dash R2 dash क्या है? Where R1 dash is R1 plus R0 and R2 dash is R2 plus R0. So let's say I'm getting this. So I1 by I2 in which ratio better? R2 dash by R1 dash. Let's say it is K. Say it is K. Okay. Very nice. So let's say this is my equation 1. Okay, let's go to the loop number. Which loop I'm going to discuss? Loop number 3. I travel again in this clockwise manner. I pass through the EMF source from minus to plus. I'll see a rise of potential. Then I travel through this I2 R2 in the current flow direction, so that will be minus R2 R2. Here also I go in the current flow arrow mark direction, so I'll see a drop in I1 R1, then back to starting point. So nice. So it is very easy now. Let us write E minus I2 R2 minus I1 R1 is equal to 0, or what should I write here? In place of I, that is, we can write I1 as, so E is equal to I1 R1 plus I2 R2. Okay. As you know, here, again from the Kirchhoff's law only, this total current I is how much? I1 plus I2. The total current is I1 plus I2. Let me write it here. This is I is I1 plus I2, and I1 by I2 is ratio is K, or R2 dash by R1 dash. So what is I1? I1 by R2, I2 is R2 dash by R1 dash, and I1 plus I2 is I. So what is I1? I1 is R2 dash, just basics of ratio and proportion, I, and I2 dash similarly, I2 is similarly, how much? I2 similarly is R1 dash by R1 dash plus R2 dash into I. That very nice. Okay. This is clear to you? Then what is capital? Then E is equal to I1 R1 plus I2 R2. So what I get E as? I1 R1 and I2 R2. If I1 in terms of capital I, I2 in terms of capital I replace here, I get slightly here I write, I get E is equal to I1 into R1. So I common R2 dash R1 by R1 dash plus R2 dash plus I2 R2 here. So R1 dash R2 by R1 dash plus R2 dash. So my job is done. So what is the R equivalent? This I can write as R1 R2 dash plus R2 R1 dash by R1 dash plus R2 dash. So what is R equivalent? As you know, E is the EMF source divided by current through the circuit total current I. So this ratio will be this. So that is R1 R2 dash plus R2 R1 dash by R1 dash plus R2 dash over. Okay, if this is the R equivalent. Okay. So, and again I'm saying you this is the R equivalent. So what is the total current I? For the total current I, total current I is I1 plus I2 is I, but total current I is E by R equivalent. So let us write this. Let me write this on the R equivalent. I have got this, the important expression. That's why I'm boxing it. Then I write what is I, E by R equivalent, E into R1 dash plus R2 dash 3 not plus R2 dash 3 R1 dash second R1 dash plus R2 dash divided by R1 R2 dash plus R2 R1 dash. Okay, this is the I. Now what is I1 then? In which ratio they are divided? I already found out that. I already told in the beginning. In R2 dash by R1 dash ratio. So R2 dash by R1 dash ratio means, already I have written this, R2 dash by R1 dash plus R2 dash into I, that is E, R2 dash by R1 R2 dash plus R2 R1 dash. I2 similarly R1 dash by R1 dash plus R2 dash, that is into I, capital I is equal to E, R1 dash by R1 R2 dash plus R2 R1 dash. Nice. So I think we have got the I1, I2 as well as the R equivalent. Everything okay? Then I naught to the bridge resistor will become I1 minus I2. So E R2 dash R1 dash by R1 R2 dash plus R2 R1 dash. Okay. So nice. Very simple now. Let's take the example. Again, I am drawing this diagram. Five ohm, 10 ohm, R not 5 ohm. This is 10 ohm. This is 5 ohm. So unbalanced but symmetric. Let's say EMF is 30 volt. So here itself I am writing what is R1, 5 ohm, R2, 10 ohm, R0, 5 ohm, R1 dash, R1 plus R0, 10 ohm, R2 dash, R2 plus R0, 15 ohm. So what is R equivalent? R1. What is R equivalent? Tell me. क्या भूल गया? R1 R2 dash plus R2 R1 dash divided by R1 dash plus R2 dash is 5 into 15 plus R2 10 into R1 dash is 10 by 10 plus 15, that is 7 ohm. So let us say this is, instead of to make it calculation, keep the calculation simple, we keep it 35 volts. Just keep this to keep it simple. So what is the capital I then? I1, I2, I1 minus I2, I2 from symmetry, I1 from symmetry. So now what is capital I? E by R equivalent, 35 by 7 ampere, that is 5 ampere. Okay, and how the I1, I2 are divided? R2 dash by R1 dash. R2 dash by R1 dash is 15 by 10, 3 is to 2. So this implies I1 will be 3 by 5 of capital I, that is 3 ohms, 3 amperes, and I2 is equal to 2 by 5 of capital I, that is I 5 ampere is capital I, 2 ampere. So I naught will be I1 minus I2, that is the current to the bridge resistor 5 ohm. So that is 3 minus 2, 1 ampere positive. That means it flows from C to D, A, B, C, D. Okay. That's it. So this is what a very simple application of the symmetry case. Just you change the R1, not change anything, just calculate your R1 dash and R2 dash. After that, your job is over. R1, R2 dash plus R2, R1 dash by R1 dash plus R2 dash. Job is over. It's simply 7 ohm. It's coming out to be 7500 plus 25, 175 by 25, 7. Okay. So whatever from beginning, whatever I discussed is like this. So from a general Wheatstone bridge, and from the general we are coming to general Wheatstone bridge, then we come to a case where it is unbalanced but symmetric. Balance, if you balance, then no issues. R1 by R2 is R3 by R4 is balanced only. So no current will flow through R5 and you can easily find the R equivalent, other currents and everything. But here it becomes a bit more complicated, but not so complicated because it's symmetric also. Using symmetry, I1 here means I1 here, I2 here means I2 here, then this is I1 minus I2. Understood this? So this is what we are calculating. So in this case, as you see, this I1 by I2, the inverse ratio of the resistance is looking like parallel. So this R2 dash by R1 dash, not R2 by R1. It's not exactly parallel, but it's similar. I get a relationship like I1 dash, I1 by I2 is R2 dash by R1 dash. Okay, so that's very simple. So R equivalent, once we can find I. Then from I, we can take inverse ratio of R dash by R1 dash, they get I1, I2. So then I naught we get by I1 minus I2. Then I give an example. Let us call it an example. Okay. Before we go to, so this is, as you know, let me write some text here. So as you all know, let me write my name is Le. Okay. My credentials I'm writing. Okay. So with this, this is my credentials. So similarly, do you know that there are there's a Wheatstone bridge arrangement with capacitors. So what will be equivalent capacitor if the Wheatstone bridge arrangement having symmetry but no, it is not balanced? Then in that case, let us write the for capacitive one also. I write this C equivalent will be C1, C2 dash, same expression, where C1 dash is C1 plus C0, C2 dash is C2 plus C0. Simple. How? Very simple. You just, in a registry circuit, wherever R is there, you write 1 by C there and job will be over. R equivalent is C1, C2 plus C0, C2 dash plus C2, C1 plus C0, that is C1 dash. C1 dash is C1 plus C0 plus this is C equivalent, I'll write. This I'll write as C equivalent. That is C2 plus C0. Okay, no, let us write the R equivalent so that things will be much better for you. So we'll write here as R equivalent, already I have discussed. R1, R2 dash is R2 plus R0 plus R2. R1 dash is R1 plus R0 divided by R1 dash R1 plus R0 plus R2 dash R2 plus R0. Then write C equivalent will be 1 by C equivalent will be 1 by C1, 1 by C2 plus 1 by C0 plus 1 by C2 plus 1 by C1 plus 1 by C0. Wherever R is there, just 1 by C you write. Then this will give you, as you simplify it, it will give you C1 this same, this, once you do this, you get this. Check that. So, how did you like it? Very simply you can do. Similarly here, I1 by I2 was R2 dash by R1 dash. Here I1 by I2 was R2 dash by R1 dash. Here, what it will be? V1 by V2 in capacitive circuit. V1 by V2 will be C2 dash by C1 dash. If you are able to do, very nice. I am sure you will be able to do this. Otherwise, you will discuss it. Otherwise, you inform me. I'll discuss it again in a new class. But this is a very helpful thing for you. This is both for JEE as well as NEET. This will help you immensely if you know this process. Thank you all. We'll meet soon again with some important electrical circuit questions. Okay. So, thank you for now. Have a good day. Okay.